Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for the GRE. We have been solving math problems out of this book here, the official guide to the GRE, the third edition. If you do not own this book already, purchase one immediately. You're going to need it. Today is our lesson number 149. 149, I believe. Let me just double check. Yes, day number 149. Day 3149. 3 is to signify the fact that we are in the third edition. Third edition, day 149. We are in the process of solving problems from the practice exam, practice test number 1 that you will find at the very end of the book on page number 368. Question number 23. In question number 23, they give us a picture. It's a geometry question. They give us a picture that looks something like this. We have two circles. Here's the first circle with the center O. With the center O, that's the first circle. And here's the other circle. And this circle has a center P. Center P. And we are further told that each of these circles has a radius of R. Radius R. What does it mean, each circle has a radius R? You see, mathematics is a language. And in the language of mathematics, symbols like R is a quantity. We don't know what that quantity, but it's a quantity. And if they tell you that each circle has a radius of R, in the language of mathematics, it simply means that they have equal radius. Their radii are equal. Because if they had different length of radii rather, then they would have said that the first circle has a radius of R1, the second circle has a radius of R2. And that would have meant that the two radii do not equal to each other. They are different quantities. If they are the same quantities, we use the same symbol. So if they tell us that both of the circles have the radius of R, that means that two radii are equal. Plural of radius is radii. Radii, not radiuses. So here we go. This is the radius here. That's R. And if you were to take a point here and go to the outermost edge and you can draw a line, that is also the radius, because we're going all the way to the outermost edge of the circle and drawing a line. That's a radius. And similarly from here to here, that is also a radius. So this is a radius, this is a radius, this is a radius. This means this triangle that we're looking at is an equilateral triangle. It's an equilateral triangle. And similarly, we have another one at the bottom here. And the question simply is, what's the area of this picture that we see here? Let me erase those R's so it doesn't look too ugly. What's the area of that picture there? The shaded region. Let's find out, shall we? Let's find out. We don't need this now. I'm going to erase it so that we can start from the top. So what we're going to do is we're going to simply concentrate on this guy on the top. Once we know the area of the top triangle, bottom one is the same thing, it's a mirror image of it. But once we know the area of this one, we can multiply by 2 and we can get the whole area. So let's look at the top one. Now keep in mind that all three sides are equal. All three sides are R. This is R, this is R, and this is R. With me so far? There are several steps involved in this problem. Reason why this problem appears at the very end there, and I'll give you the percentile at the end, toward the very end of the question, I'll give you the percentile. You will see that when this question appeared in the real exam, more than 3/4 of the people missed it. More than 3/4 of the people got it wrong. They got it wrong not because it involves complicated geometrical concepts. The concepts that are involved are very simple geometry. It's just that there are many steps to get to the final answer. It's a lot of gymnastic in terms of thinking. You just have to keep your things straight, your thinking straight rather. So let's get going, shall we? There are too many small steps. So here's the step number 1. What we're going to do first is divide this in half. If you were to divide this in half, first thing you have to understand is that since we are dropping the perpendicular, that's what it's called. It's called dropping a perpendicular, which means this angle that we see there is a right angle. And since from here to here was R, from here to here, this distance is 1/2 of R. And that's this side from here to here is R. Let's find the area of this triangle. So I told you before that we have to find the area of this entire region, and then I said let's find the area of the top triangle. Once we find it, we're going to multiply it by 2 and we'll have the area of the whole thing. I was in fact lying. we're not going to find the area of the top triangle by itself. We're going to divide that into half also. So we're going to find the area of this small triangle. Once we have the area of this thing, we're simply going to multiply it by 4 because there are 4 of them. There are 4 of them here, right here. Here's 1. Here's 1. Here's 2. 1, 2, 3, and 4. There are 4 of them. So if we find the area of that one small triangle, which is what this is, we can multiply it by 4 at the end, we'll have the answer that we need. And this is a right angle triangle because there is a right angle right there. How do we find the area of a triangle? Well, it's very simple. The area of the triangle is simply 1/2 base times height. Base times height. 1/2. How much is the base? Well, base is right here. Base is 1/2. Base is 1/2 times r. And how much is the height? Uh-oh. We don't know the height. Uh-oh. We can't go anymore. Lost it. We have to find the height. We have to find the height. How are we going to find that height? Well, it's a right angle triangle. How do you find a missing, if you have 2 sides in a right angle triangle, how do we find a third side? Obviously by using Pythagorean theorem. So let's use Pythagorean theorem. You see there are too many steps in it, that's all it is. Let's use Pythagorean theorem on this triangle and let's call this missing side h. H for height. And the Pythagorean theorem tells us that the square of the hypotenuse must equal the sum of the squares of the other 2 sides. So r square must equal h square plus, I don't want to really erase that, but let's erase temporarily. So r square, which is the hypotenuse square, must equal this side square, which is 1/2 r square, plus the other side square, which is what we're calling h. H for hypotenuse. And we're going to solve. Actually, let's erase this whole thing. We don't need any of this. We don't need the circles anymore. What we are interested in is the area of this thing right here. And what we are in the process of finding, and what we are in the process of finding is the area of one of these triangles. That's what this is. Once we have the area of one of these triangles, we're simply going to multiply that answer by 4, and we'll have the answer. We don't need the circles anymore. So let's do that. H is the unknown here. Do you understand? So let's open it first. When we open this parenthesis, we get 1/4, because 2 times 2 is 4. 1/4 r squared plus h squared. And here we have r squared. Are you with me so far? So how many r squared do we have on this side? On the left hand side, we have 1 r squared. So if you have 1 r squared, and if you subtract 1/4 from it by bringing it here, 1 minus 1/4 would be 3/4. 3/4 r squared would have to equal h squared. Would have to equal h squared. But we're not interested in finding what h squared is. We want to find what h is. So let's take the square root of both sides. Why square root of both sides? Because the square root of h squared would be just h, which is exactly what we're looking for. The square root of 3 we cannot do anything with it, so square root of 3, and square root of 4 is 2. And what's going to be the square root of r squared? Square root of r squared is just r. I'm going to bring this line all the way down, the demarcation. I'm going to keep it separate, okay? Oh, let's start with that. I don't know why. I just don't know why sometimes I get these uncontrollable urges to act really stupidly. And I find it very annoying when I have these urges, because I know myself, I don't need those urges to act stupidly. I can do that, I can do quite well without the urges. I'm very good at actually acting stupidly, that is. So that's it. H is equal to root 3 over 2 times r. Let's put it in here. Root 3 over 2 times r. And don't forget we have another r here. We have r, and when we have r, so when we multiply them together, we're going to get r squared. Let's do it out, shall we? And this represents the area of this one triangle. The area of this one triangle, let's call it triangle 1. 1/2 times 1/2 times 1/2, we're going to get 1 over 8, see 2 times 2 times 2, 1 over 8, and here we have r and r, so we get r squared, and then square root of 3. You still with me? And that was the area of one of the triangles, right here. That was what we just found here is this guy right here. And we have 4 of them. So we need to multiply this quantity by 4, and when we multiply the quantity by 4, we'll have the area of this entire thing. So let's erase this. It's no longer the area of one triangle. What we're going to do is we're going to multiply this quantity by 4. Let's multiply this quantity by 4, and it no longer represents the area of one triangle. It represents, when you multiply it by 4, what this represents is our answer. Let me write this 4 properly. So here we have 4 on the top, here we have 8 at the bottom. Let's divide by 4, 8 will become 2, and we are done. So it's going to be 1 over 2. I'm going to continue this way. So 1 over 2, right here, 1 over 2 times root 3 times r squared. Or if you like, we can also write this. We can write this quantity as, instead of writing it 1 over 2 and then root 3, we can write root 3 over 2 times r squared. There is your answer. That quantity represents the area of this whole thing. Let's see which one matches the answer. So we have root 3 over 2 r squared, and that's answer choice B. Let me quickly check in the back. This was number 23. Answer is indeed B, and the percentile here I just saw is, as I told you, it was less than, more than 3/4 of the people missed it, and the percentile is 24%. 24%. In other words, fewer than 1/4 of the people who took it got it right. 3 out of 4 people in the exam had trouble with it. They had trouble with it, as I said before, not because it involves complicated geometrical concepts, because all we did here is the area of the circle, understand what the radius is, understand how to find the area of the triangle, and how to use Pythagorean theorem. These are basic concepts in geometry. But what makes it difficult is the fact that there are too many steps to get to the final destination, and you have to keep track of those steps. Tomorrow, on day number 150, we'll finish this section. This section 6 in the first exam. Tomorrow we'll do question number 24 and 25. Question number 24 deals with permutation and combination. It's not any straightforward question. We'll do 24 and 25 tomorrow, and day after tomorrow we'll begin the first math section, whatever it happens to be. We'll begin first math section of exam number 2. We'll begin the test number 2, not tomorrow, but day after tomorrow. Okay? On day number 151. On day number 151, we'll begin exam number 2, and we'll finish with exam number 2 on day 160, and that will be the very last video in this series. Alright, I'll see you tomorrow. Bye now.